All right, let's try one that looks fairly small, but actually has a lot involved in it. This one's x minus 5, all divided by x minus 10, is less than or equal to 3. Okay, so like before, let's get everything over onto one side first. That way, it's in relation to 0. So x minus 5, all over x minus 10, minus 3, is less than or equal to 0. Now we need to worry about getting that common denominator. So I say I have an x minus 10 denominator. Let's give that x minus 10 to the top and bottom of our 3. All right, looking much better from now. Now we'll go ahead and combine these rational expressions right here. I think we can even do a little bit of work. Let's go ahead and distribute this negative 3 as long as we have it there. So x minus 5 minus 3x plus 30 all over x minus 10. We want to know where is it less than or equal to 0. Okay, just a few things that we can combine. We'll go ahead and do so. Negative 2x from combining our x's. And let's see, a plus 25. And that'll be from combining our 5 and our 30. So we want to know where's that less than or equal to 0. All right, in good shape so far. Now that we've really crunched it down into one rational expression, we're interested in where is it equal to 0. Well, this will be equal to 0 wherever the top is equal to 0. We've got to do a little bit of work with this one, but we can figure out where the top is equal to 0. We'll have to move the 25 to the other side, and then divide both sides by a negative 2. So I have 25 halves. So this, let's make a little note, is where the top is equal to 0. Okay, that looks pretty good. Now let's figure out where the bottom equals 0. That's not so bad. That would be at x equals 10. Okay, so it's around those two values that we'll go ahead and check to see what the sign is. Around a 10 and around a 25 halves. Let's get our table here. So let's see, the smaller of these values would actually be our 10. And then 25 halves, we'll put that over there. So let's check the sign, see how these turn out. So negative 2x plus 25. And the other one would be x minus 10. All right, so let's grab some sort of test value that is less than 10. So one thing I can see here is maybe I plug in a 0, that's less than 10. If I plug that in for the first one, I'd get a positive 25. If I plug 0 in for the other one, I'd get a negative 10. So there's my sign for that one. All right, on to the middle interval. I need something between 10 and 25 halves. Well, I think 11 will work out just fine. 11. So if I put 11 into that top one, I'll get a negative 22 plus 25. So that'll be positive. If I put an 11 into the bottom one, 11 minus 10 would be a positive 1. Okay, interesting. Okay, now I need to pick something larger than 25 over 2. 25 over 2 is about 12 and a half. So let's go ahead and test out something like 20. Why not? If I put 20 into the top one, I'll have negative 2 times 20. That'll be negative 40 plus 25. That'll definitely give me a negative value. If I put 20 into the bottom one, 20 minus 10, that'll be a positive 10. All right, so these two things are really being divided. So to look at our overall sign, we'll take each of these signs and go ahead and divide them. So positive divided by a negative would be a negative. Positive divided by a positive would be positive. and negative divided by a positive, negative. So what am I interested in for this particular one? Well, I want to know where it will be less than or equal to 0. So let's look for those negative values. Well, I can see one interval here, everything less than 10, and I have another interval here where it's greater than 25 halves. So let's write down those two intervals. So from negative infinity up to 10, and from 25 halves all the way up to the other infinity. All right, one last thing. We need to figure out what endpoints we should include and which ones we should not include. This one does have or equals to, so I'll include the places where the top is equal to 0. And we already marked those out. The top is equal to 0 at 25 halves, so we will include it. We never include spots where the bottom is equal to 0, so I will not include the 10. Then we'll finish it off by putting our little union symbol in between. So the intervals that represent the solution are from negative infinity up to 10, and from 25 over 2 all the way up to infinity. And then we can consider this inequality solved. So it is kind of a lengthy process, but really use that table to help you organize your information, and definitely watch at what points you can and cannot include in those solution intervals. Thank you for watching Educator.com.